Hi students, I am Dr. R. Kumar, Assistant Professor in the Department of Chemistry, J.J. College of Arts and Science, Pudukottai. Now, let us see what is the quantum numbers. Quantum numbers is to describe the location of an electron in an associated atom. This is very important in the basic concept of the quantum numbers. Now, uh, there are the four types of the quantum numbers are there. It is indicated by the small n, l, m, s, and is the quantum number is used to address an electron as follows. Some of the informations we can get from the quantum numbers, that is to determine the size, distance from the nucleus, and energy of electron in an orbit, to decide the shape and energy of an electron in a support of orbit, to find the number of orbitals and the directional positions or orientation in space, to find the number of electron and their spin. So now let us see one by one. There are four types of the quantum number, and the first some of four types of quantum number is principal quantum number, azimuthal quantum numbers, magnetic quantum numbers, and spin quantum number. Now we can see the first numbers, that is the principal quantum numbers. It is indicated by the small n, and it was proposed by the Bohr, and it is denoted by n. It determines the average distance between the electron and the nucleus, means it denotes the size of an atom, and it determines the energy of electron in an orbit where the electron is present, and it gives the maximum number of electron in an orbit is represented by this quantum number as 2n square. It gives the information of orbit, that is k, l, m, and n. The value of n is equal to 1, 2, 3, 4. The angular momentum can also be calculated by these quantum numbers. And second one is the azimuthal quantum numbers, and is proposed by the Sommerfeld and denoted by the small n. It determines the number of subcell sublevels to which the electrons belongs, and also it tells you about the shape of the subcells, and also express the energy of the subcells, that is S greater than B and p orbitals greater than the D and F. The value of L is the L is equal to 0 to n minus 1. Always n is the number of the subcell. It represents the orbital angular momentum, which is equal to h by 2 pi square root of L into L plus 1. The maximum number of electrons in subcells, that is equal to 2L into L plus 1. And another one is the value of azimuthal quantum number is L. The value of L, that is the principal quantum number, is 0. The value of L, azimuthal quantum number, is 0, and is the number of the subcell, it is S. The orbitals, the shape of the subcell is spherical, and the maximum number of the electron in the subcell is in the s orbital is 2. So for the value of principal quantum number 1, the value of L, that is azimuthal quantum number 1. So the number of the subcells, that is a p orbitals, and shape of the p orbitals is dumbbell shape, and maximum number of electron in this 6, because the p orbitals there are 3 subcells are there, px, py, and pz. So the maximum number of electron in the 6. If the principal quantum number 2, the value of L is equal to 2, and number of subcells is a d. So double temple, the maximum number of electron in the d orbitals is 10, because the 5 d orbitals is there, that is dxy, yz, zx, and dx square minus y square and z square. So 5 orbitals are, so total number of electrons is 10. So likewise, we can write the number of electrons in the subcell. And the third quantum numbers, that is the magnetic quantum numbers, it was proposed by the Zeeman and denoted by the M. It gives the number of permitted orientation of the subcells. The value of M varies from the minus L to 0 through the 0 plus L. It tells you about the splitting of the sweater line in the magnetic field, that is that this quantum numbers prove the Zeeman effect. For a given value of n, the total value of m is equal to n squared. For the given value of L, the total value of m is equal to 2L plus 1. And another one is the very important degenerate orbitals. what is a degenerate orbitals is nothing but the orbitals having the same energy are known as the degenerate orbitals. Example, for p subcell there are three degenerate orbitals px, py and pz. The number of degenerate orbitals for the subcell s cell subcell is 0. And the last quantum number is there is a fourth quantum number is a spin quantum number. It was proposed by the Goldsmith and Uhlenbeck and denoted by the S. The value of S is plus of or minus of, which gives the spin orientation or rotations of electron in its axis during the movement. The spin may be clockwise or anti-clockwise. It represents the value of spin angular momentum, that is equal to h by 2 pi square root of s into s plus 1. The maximum number of an atom, that is equal to half the number of unpaired electrons. And this table explains the distribution of electron among the four quantum numbers. First column is the principal quantum number, and the second one is azimuthal, and the third one is the magnetic quantum number, and fourth one is the designation of orbitals and number of subcells in the orbitals in the subcells. If principal quantum number 1, the value is L is equal to 0 and the magnetic quantum number also 0, the designation of orbital is a 1s orbital. So number of subcells in this only 1. If principal quantum number 2, the L value is 0 and M value is also 0. So the designation of an orbital is equal to 2s orbitals. So number of subcells in the s orbital, so only 1 orbital. And if principal quantum number 2, the value is L value is 0 and 1. So the M value is for the L is equal to 1 minus 1 0 plus 1. So this is a 2p orbitals. The number of subcells is 3. For example, if the principal quantum number 3, L values may be 0, 1 and 2. If the 0, L value is 0, magnetic quantum number is 0. So 3s orbitals and only one subcell. If the L value is 1, minus 1, 0 plus 1, there is a 3p orbitals, 3 subcells are there. If the L value is equal to magnetic quantum numbers is minus 2, minus 1, 0, plus 1 and plus 2. This is a 3d orbitals. There are 5 d orbitals in their subcells. And then likewise, if the principal quantum number 4, the L values, that is a azimuthal quantum number 0, 1, 2, 3. Magnetic quantum numbers is a 0. For the L value is 1, M value is minus 1, 0 plus 1. This is a 4p orbitals and 3 subcells are there. If the L value is equal to M value is minus 1, minus 2, minus 1, 0 plus 1 plus 2, that is a d orbital, there is a 5 subsets. If the L is equal to 3, the M value is minus 3, minus 2, minus 1, 0, plus 1 and plus 2 plus 3. This is a 4 of subcells. There are 7 number of orbitals in the subcells there. So this table explains the distribution of electron among the quantum numbers. Thank you.